Today, we will be discussing about solving problems involving the law of acceleration. To start with, let's identify and describe the different variables used in solving problems involving the law of acceleration. Force. Force is a push or a pull upon an object resulting from its interaction with another object. Like, for instance, if you were a ball sitting on a field and someone kicked you, a force would have acted on you. As a result, you would go bouncing down the field. F means net force and its unit is Newton or N. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. For example, an object was moving north at 10 meters per second. An apple is falling down. Jane is walking east at 3 kilometers per hour. When the car slows down or when you fall off a bridge. Those are examples of acceleration. A is a symbol for acceleration with the unit meter per second squared. Again, the unit for acceleration is meter per second squared. Mass. Mass is both a property of a physical body and a measure of its resistance to acceleration when a net force is applied. For example, the car has a mass of 10,000 kilograms. Your mom bought 25 kilograms of rice. Mass can also be expressed in grams. Example, 10 grams, 50 grams, etc. But here, in the law of acceleration, we are going to express mass in kilograms, since it is the standard unit of mass. Analyze the image on the screen. Can you determine which among the shopping carts is the heaviest without weighing it? How? Let's check it out. What have you noticed with the movements of the shopping carts? The cart that moves slower is the heaviest, while the cart that moves faster is the lightest. This proves that as the mass increases, the acceleration decreases. And as the force increases, the acceleration also increases. It is stated in the Newton's second law of motion, which is the law of acceleration, that the acceleration of an object is directly proportional to the magnitude of the net force acting on it and is inversely proportional to its mass. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. This verbal statement can be expressed in equation forms as follows. Acceleration is equals to the net force divide the mass of an object. The equation is often rearranged to a more familiar form. The net force is equated to the product of the mass and acceleration. From the given equation, how will you get the mass of an object? Mass is equals to the net force divide the acceleration of an object. Again, mass is equals force divide acceleration. How about acceleration? Acceleration is equals to the net force divide the mass of an object. Again, acceleration is equals to force divide the mass. Let's try to solve sample problem number 1. Suppose a ball of mass 0.70 kg is hit with a force of 12 Newton. What is its acceleration? To answer the given problem, let's start by writing the given. Mass is equals to 0.70 kg. Again, the mass should be expressed in kilogram. Force is equals to 12 Newton. Force is expressed in Newton. So what is the acceleration of the object? Using the equation A is equals to force divide mass, where F is equals to 12 Newton and mass is equals to 0.70 kilograms. 12 Newton divide 0.70 kilogram is equals to 8.4 meter per second squared. So the acceleration of the ball is 8.4 meter per second squared. Do not forget to write the unit of the variable. The unit for acceleration is meter per second squared. What if we're looking for the force? Let's try to answer problem number 2. What net force will give a 1,000 kilograms car an acceleration of 5 meter per second squared? To answer the given problem, let's write again the given. Mass is equals to 1,000 kilograms. Again, mass is expressed in kilogram. Acceleration is equals to 5 meter per second squared. Acceleration is expressed in meter per second squared. So what is the net force of the object? Using the equation F is equals to mass times acceleration, where mass is equals to 1,000 kilograms and acceleration is equals to 5 meter per second squared. 1,000 kilogram times 5 meter per second squared is equals to 5,000 Newton. So the net force is equals to 5,000 Newton. Again, do not forget to write the unit of the variable. The unit of force is Newton. Now, let's try to answer Sample problem number 3. What is the mass of a truck if it produces 14,000 Newton while accelerating at a rate of 5 meter per second squared? In this problem, we're looking for the mass. Let's write again the given. Force is equals to 14,000 Newton. Force is expressed in Newton. Acceleration is equals to 5 meter per second squared. Acceleration is expressed in meter per second squared. So what is the mass of the truck? Using the equation, mass is equals to force divide acceleration, where force is equals to 14,000 Newton and acceleration is equals to 5 meter per second squared. 14,000 Newton divide 5 meter per second squared is equals to 2,800 kilograms. So the mass of the truck is equals to 2,800 kilograms. Again, do not forget to write the unit. The unit of the variable or the mass is kilograms. I hope you learned from this session. Thank you for watching.